Okay, question 7 is about nuclear fission. Here's what we learned. We take a fissionable material like uranium, 235, 92. We fire a neutron at it. That neutron has to have the right velocity. If it does, it gets absorbed. This makes this unstable, and therefore it splits. And it splits into 2 smaller nuclei, which we call daughter nuclei, and it releases 2 to 3 neutrons, and these go on to form the chain reaction. So that's the basic idea. So we take a fissionable material like uranium-292, we fire a neutron with the right velocity. If it's at the right velocity, it gets absorbed. This just messes up the nucleus and makes it unstable. Then it splits. We make 2 smaller daughter nuclei and some more neutrons, and then they can go and impact more nuclei, and it sets up a chain reaction, and then boom, bomb. And then in a nuclear power plant, we just control the neutrons. So a neutron hits a nucleus of uranium-235 and causes the nucleus to, well, the neutron gets absorbed first, and then it splits. Each fission releases energy, 2 daughter nuclei and some neutrons, 2 to 3 neutrons. In a nuclear reactor, 1 fission can set off a controlled chain reaction. Next question. Both uranium-235 and oil can be used as energy sources. 1 kilogram of uranium makes 45,000 units of electricity. 1 kilogram of oil makes 5. How much extra oil do we need? So it's just a ratio. We just need to find the ratio of that. So how many times does 5 go into 45,000? 45,000 divided by 5 equals 9,000 kilograms. Lovely question, that. Both using nuclear fuel and burning oil produce harmful waste products. Give a harmful waste product from each process. Nuclear fuel, nuclear waste is going to make radioactive isotopes. Burning oil, try to stick to the top one. You can use the bottom one if you want, but carbon dioxide, which is a greenhouse gas, leads to global warming, which all of you know off by heart. Do not say it pollutes. All right. The other one we could do, sulfur dioxide, because it leads to acid rain, or any other named one. You cannot just write pollution. Next one, we've now got a 6 marker. It's quite a nice 6 marker, and I think there's a nice way of writing this out so that you actually get loads of marks. So the first part we need to know, inside here, so I've got a little alpha source emitting radiation, and then there's a detector here. Let's put a G for Geiger counter, although it's not a counter, it's just a detector. And then what's going to happen is the smoke will go in the gap. The alpha ionizes it, and that causes it to form a cloud of charge, whether we want to call it positive or negative. Let's put some negatives. And what this does now is this sets up a current that sets off the alarm. So the crucial part is we ionize the smoke. This makes a charge, and this leads to current flowing around, which sets off the detector. Woo, woo, woo. Or as my kids say, dinner's ready. So going on to the next part. So we know that we're going to have to choose alpha. So that's fine. So it's definitely not you. Otherwise, we're just going to, with its huge penetration, it's going to irradiate my family. The next bit is we've got to choose between 433 years or 10 days. I don't want to be replacing my smoke alarm every few days. That's a risk in terms of detecting fires. There'll be no alpha particles to ionize the air. And I don't want to take a risk in replacing it, because that's going to give a risk to myself. And now we can see the one we want, americium-241. So here's my best way of answering it. And I'm going to start by just saying, what do I need? And then I'm going to finish with which one's the best. So I need an alpha source so it can ionize the smoke. Got 2 marks already. And create an electrical current to set off the alarm. I don't need to start talking about minuses and positives in there. If you want to, you can. But it's just, I need to ionize the smoke and create an electrical current. This will set off the alarm. 3 marks already done. Next part. I need a longer half-life, so I don't need to replace it, as that will risk contamination to the owner. As it's ionizing, it's going to cause tumours. So the last part is, and the best choice is americium-241. Done? Not done. Done.